and then we could have a mite, which is now the same volume as the regular tetrahedron, and it's the same volume as this quarter octahedron, and this is a mite. Now if this would be the synergetic scale, if it would be, it's not, I'm just saying if it would be, even in this scale, the synergetics only could make 2 frequency cubes, because these blocks, which work with star of David, which I'm going to show very soon, only builds 2 frequency cube. I mean, you cannot go lower. I of course can go lower by dividing this and make a small cube. I haven't finished it, but we would put like that right here and here, like that. So even at this scale, the system is still inferior versus the system using irregular tetrahedron as the true minimal unit volume blocks. In other words, if we would use these irregular tetrahedrons, only these 3 blocks, then we are operating at the lowest scale with the smallest blocks, and everything is consistent because these blocks, only these 3 blocks, can build a whole matrix, isotropic vector matrix. It can be hexagonal, dodecahedron, whole concentric hierarchy, and way beyond. But we are true to our one scale. We have our prime vector is same. It doesn't change in flip-flopping like in synergetics. Appears there is a confusion between a radius of 2 touching spheres and the diameters of two spheres. So these inconsistencies been going on for decades, and it's kind of still not clear. But this is our operating system, irregular tetrahedrons, because they are more diverse, and we're using only one prime vector. So for example, I can build a cube from 6 double corners. 1, 2, so here we have double corners, and I can build a cube, thus aligning these to make square base pyramids. They are offsets. They are actually a half a irregular octahedron. Looks like this. This is a half a irregular octahedron. Okay, so we have that. So we have 3 of those, and yeah, indeed they're making a cube. There you go. That's our cube. Now as you see, all the cubes I have built are all the same size. There is no inconsistency. It's all the same. So synergetics cannot build at this scale. Synergetics only can be at the larger scale. It's like we would say that the smallest atom is a helium and not hydrogen. But the reason why it's hydrogen, because it is the smallest atom, and synergetics, by following that kind of rule, they're starting somewhere with the helium or something like that. Synergetic small cube would have to have 9 blocks, since the 2 frequency cube, even though they call it 1 frequency cube, it's a 2 frequency cube. 72 divided by 8 would be 9 blocks. They would have to have a cube of 9 blocks, but they don't, because that is actually impossible. I can make a small cube from an octant. Here, now let's see the octant. Okay. We have again 3 solid kites, making a regular tetrahedron and an octant. So I can make a cube small cube from an octant, and I'm gonna have some blocks left over because cube is 6 blocks, octant is 8. Remove this, put this one in here, and we have a cube. Now I made this small cube from an octant, as you have seen. Synergetics cannot do it, even though Synergetic's octant has 12 blocks. You cannot build a cube. I can make a cube from blocks making up the quarter regular tetrahedron. It is our quarter regular tetrahedron. I need one more here. This is a quarter regular tetrahedron. 4 blocks. So I don't have enough blocks to make a cube, but considering if I would have endless number of these, then I can make a cube. Synergetics cannot. Synergetics as a manufacturer cannot do nothing with the blocks derived from a quarter regular tet, which looks like this. They only can make a regular tetrahedron, and of course a regular tetrahedron consists of 4 of these. But so, look, I can have it like this. I fold these back upon themselves, and voila, there is a cube. I have to add 2 other blocks, but these I made from a blocks derived from. As a matter of fact, this quarter regular tetrahedron, these 2 blocks, this one and this one, can build a whole concentric hierarchy and way beyond. Only these 2 blocks if I have endless number of them. So, and these are found in a quarter regular tetrahedron, and now just consider it different. I can build a whole hierarchy and way beyond, but Synergetics cannot do nothing with the quarter regular tetrahedron blocks. Everybody knows that, and nobody managed to build anything. So it's impossible. I can make a cube from a 6 double corners, which I just showed Synergetics cannot make a cube. I can make a cube from a tri-rectangular tetrahedrons, which are here. These are tri-rectangular tetrahedron. According to Coxeter, Fuller calls them mites, and he also took the invention of this block that he invented it. Well, he didn't. We knew about these blocks long time ago, or other people's had. All right. I want to show again what you can build from a mite. For as we see, 1, 2, 3, 4, 5, and I need one more. 6. Now, as we see, and this is very important, that these blocks they called mites. Now, if I would want to build a cube, it's impossible. I can build a hexahedra, and it looks like this. I make a site, which is a tetrahedron, which it's a very unique block actually, because it has all the faces of identical surfaces. All the angles are same, all the edge lengths are alternating. Well, this one is comparable with this one, and then these 2 are a square root of 3. But now we have this tetrahedron, and then I can put these mites like that, and I have a hexahedron made up of 6 mites. It's basically, again, you see that these blocks are larger. Mite is twice as big than a double corner because it's composed of 2 double corners. But this is the hexahedron you can build, but it's not a cube. So let's see if we can do this in a cubes. How many cubes? Well, we're going to have 2 cubes actually. So we have these tri-rectangular tetrahedrons, and now I'm going to fold them up back to our irregular octahedrons, like half octahedrons, and we're going to make 2 cubes.